Hello, everybody. Welcome to a new episode of the Dissenter. I'm your host, as always, Ricardo Lopes, and today I'm joined by Dr. Fernanda Ferreira. She is Distinguished Professor of Psychology at the University of California, Davis. Her area of research is psycholinguistics. She uses basic insights from formal linguistics, especially theories in sentence, phonology, and syntax to develop models of processing. And today we're talking about modifiers, speech disfluencies, misinterpretations, and how people deal with them, the study of reading and information processing through eye tracking, and some other related topics. So, Dr. Ferreira, welcome to the show. It's a big pleasure to everyone.
Thank you very much. It's really great to be here. Thanks for the invitation.
Great. So, perhaps to introduce people to the topics we're going to explore here and also to you a little bit more, could you please start by telling us about the kind of work you specifically do, the questions from linguistics you are most interested in, and how you got into it?
Okay, I guess I'll start at the highest, sort of at a high level of generalization. I'm interested in language. I've always been interested in how language works, and I began to be interested in the question of how humans process language when I was an undergraduate. I became fascinated by questions of human nature and what made humans unique. What is the balance between nature and nurture, and those sorts of questions. And in the course of pursuing those topics, I ended up taking classes in philosophy of mind and epistemology, as well as classes in psychology, of course. And I never actually took a class in linguistics when I was an undergraduate because we didn't really have a linguistics program. But through some of these other courses, I began to realize that there was this area of research that looked at language processing from a looked at language from a kind of a computational and biological point of view. And then with psycholinguistics, I discovered an area where people were looking at questions from a processing, computational, psychological view and trying to understand how the language system worked together with other cognitive systems like memory and decision-making and attention, and how all those cognitive systems that are not specifically dedicated to language combine with language systems to enable us to speak and to understand each other. So in my own research, I've focused on questions like how we use the grammar of our language in real time, to process sentences. So, for example, we know that in English, we tend to place our modifiers of nouns before the noun, whereas in Portuguese, they come after the noun. And so this is the kind of information that a listener can use online to anticipate what sort of word type is likely to be coming up next. And in production, it's information that we would be using to constrain the form of our sentences. So I guess then my general approach to studying language has been to use primarily behavioral methods and eye tracking to understand how people generate linguistic representations in real time, and how the language system works cooperatively with other cognitive systems to allow these representations to get generated, whether it's in comprehension or in production.
Mm-hmm. So let's get into some more specific questions. I would also want to ask you some of the methods you use in your research, but perhaps it's easier to get into some of the topics, and then we can go through some of the methods as we talk about them. So you are interested, for example, in uncovering the mechanisms that enable humans to understand and generate language in real time and in cooperation with other cognitive systems. So what are these mechanisms, and how do you approach these kinds of questions?
Well, so one kind of mechanism that people use when they are trying to understand language is that there's a term we use in psycholinguistics and computational linguistics. We refer to the parser, and the parser is the component of the language system that takes this continuous stream of input, whether it's auditory or signed or visual, in the visual modality, and breaks it up into pieces like words and grammatical phrases, and uses those phrases to obtain an understanding of what a sentence might mean. And so the parser, in order to do this, is going to consult grammatical information. So information about the rules of the language that allow words to be put together, and possibly, in some languages at least, rules about things like agreement, like grammatical agreement. So in English, we don't have a lot of it, but in Portuguese, for example, we have gender agreement. And that kind of information can help the processor figure out how to chunk this continuous stream of sound or of squiggles on a computer screen into discrete units like words and phrases and so on. And so in my research, I've looked at the question of how this grammatical knowledge is consulted in real time, and what the language processing system does when it's faced with more than one possible interpretation that it could draw of a constituent. Because there's a lot of ambiguity in language. There's a lot of situations, or the parser will often find itself confronted with input that can receive more than one grammatical analysis. Things like I saw the boy with the binoculars. In that sentence, there are two possible grammatical analyses. You used binoculars to see the boy, or you saw a boy who had binoculars on him, on his person in some way. And so the question is, how does the processing system decide which interpretation to get? And a lot of my work has been centered around questions like that, where we focus on information sources like, well, maybe the system tries to compute the simplest analysis. And if that simple analysis is not sufficient or gets blocked in some way, then the system has to construct an alternative. Then it goes to the more difficult analysis, but the default is to construct a simple analysis. Or maybe the system looks at the context and says, well, in a situation like this, it's very likely that somebody would be using binoculars as an instrument, and therefore I'm going to compute that analysis. Maybe prosody plays a role, so the way that the sentence is pronounced. So if I say, I saw the boy with binoculars, I might be sort of indicating that, actually, as I say that, I don't know which one would be more likely, but there are claims in the literature that one way of saying it versus another way will push you towards one analysis or another. So in my research, we have tried to understand these questions using methods like anything from acceptability judgments, which are very cheap and easy to get, all the way to things like eye tracking. And we have done some fMRI and ERP research as well, although cognitive neuroscience is not my core area of research.
Mm-hmm. We will come back to eye tracking and also to how people deal with, as you said there, the ambiguities of language. But now I have another aspect of your work that I would like to explore here. So you've also done some work on how the position of modifiers in English specifically influences how words are encoded and later on retrieved from memory. So how does that occur? And is there a difference between how people encode and process pre-modifiers versus post-modifiers? And by the way, what are modifiers to begin with?
Okay, so I'm actually looking at a presentation that I gave on this topic just to help me remember some details. And
Sure.
then a very important point to begin with is that the work on pre-nominal versus post-nominal modifiers that I've done is entirely led by my former graduate student, Hussein Karimi. And Hussein is now at Mississippi State University. When he worked with me, he was really interested in this question of how modifiers influence our interpretations of language. And so he partly came to UC Davis to work with me because he wanted to explore this topic with me. But I need to give credit to Hussein that this research was designed by him, led by him. He's the one who kind of formulated the specific research questions that we asked. But he started from work that I had done before I got to know him, probably when he was still a little boy or maybe not even born yet, work that I had done with my partner, John Henderson, where we looked at the interpretation of garden path sentences. So these garden path sentences are sentences that have a syntactic ambiguity in them, and they're called garden paths because you tend to go one way in your interpretation of the ambiguity, and the subsequent material in the sentence contradicts that analysis and forces you to have to go another way with the sentence. And the classic example is the horse raced past the barn fell, which everybody hates, and it doesn't really make a lot of sense, but it does have a legitimate analysis. The horse that was raced past the barn fell. That's what the sentence actually means. And in English, we can delete some of those optional function words. So when people get the horse race past the barn, they think they're done. They think they have a complete active clause. And then they get this verb fell. And it's like, what am I supposed to do with this? I can't figure out where this is supposed to go. And so they struggle and they finally reanalyze the sentence. In the work that I did with John Henderson, we looked at sentences like, while Mary bathed, the baby played. And in a sentence like that, if you get while Mary bathed the baby, you would be tempted to treat that as a chunk, that Mary's bathing the baby. So you get while Mary bathed the baby, and then you get a word like played, and you've been led down the garden path. It turns out the baby's playing and Mary's bathing herself. And so in that work, in the work that I did with John, we showed that if you take that phrase, while Mary bathed, the baby played, if you take the baby and you lengthen it with modifiers, so you have the baby that was cute and cuddly. So the full sentence is, while Mary bathed, the baby that was cute and cuddly played. You really make the garden path more severe. The garden path becomes far more hard. It becomes far harder to recover from. And yet we show that if you have a sentence like, while Mary bathed, the cute and cuddly baby played, that's not harder than just the baby. So the core idea here is that we've got a noun phrase, the baby, and it can be modified with something like cute and cuddly, like all babies are cute and cuddly, right? So it can, and in English, we can either say the cute and cuddly baby, or we can say the baby that's cute and cuddly. And that's the pre-nominal versus post-nominal distinction. We can either put the adjectives before the noun, which is kind of the default, or we can put them after the noun. And so what this work that I did with John Henderson showed a long time ago is that if you put the modifiers after the noun, you make the garden path more severe. So Hussein Karimi came to me in the mid-2000s to work, actually after 2010, to work with me on this, to pursue this issue further, where he wanted to look at the possibility that modified nouns in general are richer and that we remember them better. Mm-hmm. So if you have a sentence like, I saw the cute and cuddly baby versus just, I saw the baby, cute and cuddly adds information that makes the concept of baby more memorable. And so we started out with doing some experiments where we showed exactly that any noun in a sentence that's modified will tend to be remembered better than a noun that isn't modified. So that just kind of established this enhanced memorability of any noun in a sentence that has received a modifier. Let me know if I'm going on too much, or is this okay?
Okay. No, that's perfectly fine. Yeah.
Okay, so having shown that a noun in a sentence that has been modified has a richer representation in memory. Hussein then wanted to know whether it matters if it's I saw the cute and cuddly baby or I saw the baby that's cute and cuddly. In other words, we already know that modification makes the noun richer, but is there a difference in how rich it becomes with modification, depending on whether the modifiers are prenominal, that is, they occur before the noun, or postnominal, they occur after the noun? And so we did a series of experiments where we showed that if you give people a sentence with something like, the dog chased the angry cat, people are more likely to continue to write a follow-up sentence that is about the cat than about the dog. And we showed that that effect is even greater if the modifier is after cat rather than before the cat. And in other work, let me just consult this summary that I have here just to make sure I don't get anything wrong. Right, and the information in a noun phrase is read faster when it has postnominal modifiers than when it has prenominal modifiers. So in general, what this seems to suggest is that when you have a phrase and you're trying to interpret it as a listener or a reader, you get something like the, and then the best thing is to get the noun next, because the noun is the boss of the phrase. So the cute and cuddly, if I'm saying in English, the cute and cuddly, your processing system is in a state of limbo of like, the cute and cuddly what? If you say the baby that's, okay, now you have been told what is the entity that's at issue here, and then you get the modifier, and you can kind of conveniently attach that modification to something that you already have a token in your mental representation for. So our work suggests then that the head of the phrase is the boss and is the thing that you're processing is centered around. And so this leads to some really interesting questions, like why does English work the way it does? And why in general are there any languages where the head occurs after its after its arguments or after its modifiers? So English is a language that is generally heads occur first, but noun phrases are the one place where we actually can postpone the head. And what we show is that actually leads to processing costs. So really, it would be better if languages worked so that heads always occurred first and consistently occurred first. But of course, there probably are other trade-offs that are making head initial languages not necessarily more efficient than head final languages. But at any rate, that's kind of the story about head initial versus, about prenominal versus postnominal modification.
Mm-hmm. So another topic I would like to ask you about is speech disfluencies. So first of all, what are speech disfluencies? And if I got this correctly, I got from your work and the work of other people that there are 4 different types of disfluency: filled pauses like and stuff like that, unfilled pauses, repetitions, and repair. So could you tell us about that?
Sure. So no doubt in this video, you've already heard a lot of examples of disfluencies because all of us use disfluencies and display disfluencies when we're speaking. The idea is that, see, there we go. There's a disfluency right there. Yeah, you basically laid out the types of disfluencies that are out there. There are the first 3, the filled pauses, unfilled pauses, and repeats are kind of tactics for buying time. And then the repairs are the kind of disfluency that we have to invoke when we didn't quite plan as effectively as we could have, and we've made a mistake and we need to correct it. We could actually even talk about another kind of disfluency, which we could maybe refer to as an undetected error, where we say something incorrect and our interlocutor might say, put the milk in the stove. You mean the fridge, right? And you say, oh yeah, you know what I mean, kind of thing. So disfluencies are really fascinating because they are a really great example of the way that we have these linguistic representations. We have these grammars that we can consult that enable us to produce and understand sentences. But when we're applying them in real time, we often find ourselves not able to retrieve the information that we need as quickly as we would like to maintain full fluency. So there might be a word that's rare or that's escaping us, or I can't quite remember your name, so I put in an or I pause, or I just say the as a way of getting extra time. So disfluencies, where disfluencies tend to occur can give us some insights into what kinds of constituents or words or phrases are hard for the linguistic system to retrieve, or for the memory system to retrieve. And in work I did recently with my graduate students, Nora Bayer and Nene Chantaveran, both of whom are now have their PhDs and have moved on, we actually tried to look at the question of whether people, as they become older, become more disfluent. So older adults are thought to become more, our impression is that they become more disfluent as they age. They say and they pause more than younger people do. But the evidence on this point has been really mixed in the literature. And as you can imagine, it's pretty hard to study how disfluencies change with age, because what you really want to do is follow somebody longitudinally. You want to start with someone in their 20s, record how many disfluencies they produce, then record them in their 30s, and then they're in their 40s, and then in their 70s and 80s. Of course, no one's going to live long enough to do that study. So it's really a tough question to address. So most of the work that's being done is what we call cross-sectional, which means you compare some young people, count how many disfluencies they produce, and some old people. But that introduces all kinds of confounds. It's not the most powerful way to get at the question. So in this study, what we did, and it was inspired actually by an incident where I was listening to the news, and they were interviewing our former governor of California, Jerry Brown, who was governor of California fairly recently, and he was also governor of California in the 1970s. And listening to him in the current times, I was struck by how disfluent he was. Not that he was super disfluent, but I remember in the 70s, he was just smooth, you just seemed to make no mistakes at all. He's talked the way people could, would read a speech or something. And I thought, geez, this would be a really cool way to look at this question longitudinally, is to go on YouTube and find videos of people being interviewed at multiple times in their lives. Take somebody like Jerry Brown. There are recordings of him being interviewed at different stages of his life. So what we did was to collect YouTube videos of people like Oprah Winfrey, David Bowie, Jerry Brown, all kinds of people who by necessity are famous, because most people who will be interviewed multiple times over their lives and who's would then be up on YouTube would tend to have a little bit of fame associated with them. And we counted the disfluencies in their speech at the different times of their lives. And what we discovered is that actually people do not become more disfluent as they age, contrary to what anyone would have expected. What we did observe is that older adults have what's called enhanced lexical diversity, meaning that if you look at the set of words that people produce as they get older, they display richer vocabulary. So older people have access to more words. And we know this from lots and lots of research on aging, if there's one thing that happens to you with increasing age that's good, is that you know more and more words. But as you know more and more words, they do get harder and harder to retrieve, because it's sort of like rummaging in a drawer that's full of stuff. And the more stuff that's in there, the harder it can be to find the exact thing that you want. And so the slight tendency for more disfluency that we did observe in older adults could be pretty much entirely explained in terms of their wish to retrieve a word that was a little bit more precise, a little bit less frequent, that was therefore probably a little bit hard to retrieve, and they needed a little bit of extra time in order to pull it out of their mental dictionary or lexicon. So sorry, that's like a very long-winded description, but it tells us that we can look at questions like, how do people age? What happens to the language system with age? What's the relationship between memory and language? By examining something as simple as just people's speech and counting up how many uhs and ums and repairs they produce in that speech. So that's all on the language production end. I haven't talked about language comprehension and disfluency, so I'll just tell you really briefly that the question that we can ask in is it okay? Do you want me to continue with it?
Yes, yes. And then I will also have some follow-up questions to all of what you're saying there. But yes, please go ahead.
Okay, so the thing with disfluencies in comprehension is that when I'm doing that, you as the listener are kind of on hold. You're waiting, so your parser, your language processing system that's been engaged is now in a state of being on hold, waiting for the speaker to kind of resume the processing. Similarly, if I produce a mistake and then have to engage in a repair, you as the comprehender have to invoke probably inhibition mechanisms that delete the word that I said and replace it with the word that I meant to say. So if I say something like, I did this research with Nora, I mean with Hussein, you initially built a representation where you understood me to be saying that I did this research with Nora. But if I then say, no, I mean Hussein, you need to strike that from the record, kind of like a jury that's told by a judge, forget what you were just told. You need to remove that from your mental representation and replace what I said with the correct word that I intended. And what we showed in some really, I think, fun research that I did with a former postdoc named Matthew Lauder, who's now at the University of Richmond, what Matt and I showed is that when people get something like, put the milk back in the stove, which is going to be corrected because that's a very common kind of speech error that people will make, what listeners do is they right away begin to detect that you have made a mistake because it's not plausible to put milk in a stove. And what we showed using something called a visual world paradigm, which is about eye tracking, which I guess is something we'll get to later, is that if you show people pictures of things in a kitchen, and I say, put the casserole in the stove, your eyes go to a picture of a casserole, your eyes go to the image of the stove. But if I say, put the milk in the stove, your eyes will go to the milk, but they don't even tend to go to the stove. They go, you look directly at the fridge, as if your autocorrect brain mechanisms as you're processing language are saying, forget stove, that's not what the person meant, that's a mistake. So we process disfluencies really efficiently because we're able to use what some people in cognitive science refer to as our priors, or you can just think of it as world knowledge and plausibility information, which tells us that milk doesn't belong in a stove, that stove and fridge are words that people are likely to confuse with each other. And what you're trying to do as a listener is to uncover the communicative intention behind what the speaker is saying. You're not only using the literal words in order to do that. So that's another thing then we can learn by studying disfluencies, this time in comprehension, we can get a really good window into the way that our brains autocorrect and filling in mechanisms work. So it's not just our phones and our devices that are good at correcting our mistakes, but our brains are good at doing that too.
Okay, so several questions about all of that. So the first one is it that every time people use a filled pause, an unfilled pause, a repetition, or a repair, you classify it as a disfluency? I mean, I'm asking you that because since it's so common that we use these kinds of disfluent or have this sort of disfluent behaviors while talking. I was wondering if it's always problematic. I mean, cognitively, for example, since you also mentioned there comparing younger people to older people in terms of rates of disfluency and all of that, I was wondering if it would also be tied to perhaps some sort of cognitive issues, cognitive decline, or something like that. So is it always cognitively problematic if we use these sorts of disfluencies?
So that's a really interesting, that's a really important question. So in production, what we have shown in other work that I did with a former colleague named Joel Nigg, who's an expert on ADHD, we looked at adults who had been diagnosed with, had received an official diagnosis of ADHD when they were young, and we compared them to demographic controls. So people who were the same education level, roughly the same age, who had same income level and so on, who had not ever received an ADHD diagnosis. And interestingly, what we showed is that people with ADHD do not produce more disfluencies than people who had never been diagnosed with ADHD, except for the repair type. So what that seems to suggest is that if you've had ADHD, perhaps, as you might expect, your inhibition mechanisms aren't working quite as well or as efficiently as they might in other people. And as a result, you'll say the wrong word a little bit more frequently than someone who's never had ADHD and have to make a repair. So what this kind of suggests is that uhs and ums and pauses are actually a good way to plan. Okay, so I was talking about that in cases of ADHD, we can see that disfluencies are, by comparing individuals who've had ADHD to those who haven't, we can get a picture that tells us that pauses are an effective way to buy time, and that in some ways it's not a matter of never being disfluent. It's kind of like picking your poison. Do you want to be disfluent by carefully planning and pausing and saying uhs and so that you don't make a mistake? Or are you going to weight more heavily the system operating so that you don't make any pauses, but then that increases the likelihood of errors? So it's not really a matter of ever, I don't think any mere mortal can ever be perfectly fluent. And it just is a matter of whether you're in a situation where you're going to weight precision very carefully and therefore produce maybe more pauses, or whether you're going to weight fluency more heavily and therefore increase the potential for making errors, which will necessitate a repair. That's on the production side. On the comprehension side, it's super interesting to think about disfluencies as cues. And in fact, if we go back to the work of the pioneers in this field, like Herb Clark and Tom Wasso, this is actually what they've argued, that when people are interpreting language, they use disfluencies as information. For example, if I say the cat, like that's a little bit unexpected because cat's a pretty easy word to retrieve. If I say the feline, like that is, the is a little bit more expected because feline is a slightly rarer word. So if you hear me produce an or an perhaps you can get yourself prepped for a slightly less expected word or concept. And there's really cool research by people like Jennifer Arnold demonstrating that this is true, that you can use disfluencies as cues that somebody's about to refer to something that's not yet maybe introduced or has not been talked about for a little while. And in research I did with Carl Bailey, we showed that disfluencies can tell you that you're about to begin a new clause in a sentence, because we tend to produce ums before the beginnings of, at the beginnings of clauses. Nobody's disfluent at the end of the sentence. So nobody says, John went to the store, like that doesn't make any sense. But we would say, John went to the store. So these disfluencies can be used as information about what a speaker is likely to say. So they help the listener get a head start on what's about to happen. Plus, there's one more function of disfluencies, I should say, because we now have disfluencies in written language as well. So if you, especially in casual writing, like social media or in instant messaging or direct messages to people, we'll often insert an or an because we know that they actually convey a little bit of meaning. If I say something like, I heard about your story, you know, that sort of is, I'm using there as kind of a word to suggest skepticism about your, that story is, you know, about the concept of the story here. So disfluencies have a number of potentially useful functions.
Mhm. And with all of those disfluencies that we tend to have, and sometimes misspoken words or using even the incorrect words and all of that, how often do comprehenders misinterpret language? Actually, does it occur often or not? And with all, of course, with all the ambiguity surrounding language and all of that.
I'll give you two answers to that question.
Okay.
One is we can't really know, and the other is that based on what we know, probably less often than we might worry, we misinterpret each other. So on the one hand, it's very hard to know how often we misinterpret each other because misinterpretations are private. I can't tell by just sort of looking at you right now to what extent you are understanding each and every word that I've said, because I don't have access to your mental states. And we know that, well, you know, before this interview started, we talked a little bit about speaking Portuguese, and, you know, I can understand Portuguese far, far more easily than I can speak it, because I can piece things together, I can use context and comprehension, and I can fake it. I can pretend that I'm understanding and then hope that something the person says subsequently clarifies the word that I don't actually know, and I don't want to admit that I don't know it, so I'm pretending. So we really need to do experiments in order to get at misinterpretations. And what experiments like the ones we've done in my lab with people like Kyle Christensen, for example, have shown is that indeed people can be quite bad at understanding language. They misinterpret the syntactic structure. They even get the words in the sentence wrong. We've shown that people interpret a sentence like the dog was bitten by the man to mean that the dog bit the man, because it's much more likely that a dog would bite a human than the other way around. And so and we know from really interesting work going back to the 70s that Lynn Reeder, for example, did on the so-called Moses illusion, where if I ask you how many of each kind of animal did Moses take on the ark, a lot of people will just say, oh, 2. But what they really should say is, you mean Noah, not Moses, because that, you know, the way the story goes, it was Noah and not Moses. So the Moses illusion reveals that people often will not understand the language correctly. And these autocorrect mechanisms are so robust that sometimes they work in such a way that they're fixing the input for us and we're not even aware of it. And I might be trying to tell you something unexpected, but your systems for processing noisy information are smoothing it out, but it may be distorting the message that I'm trying to convey. So That's one answer, is that we know from a lot of research that people misinterpret each other fairly often in our experiments. But now, real life. How often do people actually in real life misinterpret each other? Because the thing is, in our experiments, we've designed our stimuli to be confusing. We've designed, the dog was bitten by the man. I've used the passive structure there. I've told you about something implausible because I want to lure you into misunderstanding that sentence. And the same goes for garden path sentences. So we can't base our estimates on how often people misinterpret each other and misinterpret language on the results of experiments, because those experiments are designed to elicit misinterpretations. But what we can, what some researchers have done, not me, I think people like Doug Rowland and Jan Jurasky have done this kind of work, is to look at big corpora of language, just big chunks of naturally spoken language, and looked at how truly ambiguous things are in real contexts. And what they show is that when you take into account all this additional sources of information that people can rely on, language isn't as ambiguous as we might think. And so it's probably the case that we misunderstand each other a lot less than our experiments would suggest, because we normally have a lot of opportunities to clarify what we meant. And just generally, the signal in real conversations is much richer than it is in experiments. In experiments, people are in a darkened room and they're looking at single sentences on a computer screen. In real life, you can use my speech, but you can also use my gestures. You can use what I've said in the previous 45 minutes, all of these things to help you interpret. And you might also know some things about me. So you might know that certain errors that I tend to make in speech. So it's kind of a different situation in real language. So what I would say is that language, fortunately, the language systems have evolved to be very, very efficient and to enable us to communicate. Nevertheless, we can't say that we always understand each other correctly, right?
Right.
The world is full of misunderstandings.
Yeah, I was actually going to say, if anything that I'm about to say is incorrect, please correct me. But I was going to say that in real life, I mean, as you said there, we have many more cues to draw from, like, for example, non-verbal cues, body language, gestures. And so, for example, if I hear someone using an incorrect word, perhaps they're pointing at something and I immediately understand what they meant by what they were saying, right? And sometimes by intonation or something like that, or perhaps sometimes people misspeak, but then the next sentence they clarify what they mean, or perhaps with the next sentence we have added context to what they said previously, and then we understand really what they were trying to say. And also, I guess that even the talker, the person who's speaking, also reacts to how the other person reacts to them talking. And perhaps there are instances where we understand that perhaps we said something that the other person might have misunderstood, or we might have misspoken in some way, and we go back and add more information or correct ourselves. Or sometimes, I guess, what happens is that we just misinterpret what people said, but it's just something that doesn't matter that much, and so it makes no difference at all for our interaction, for our life and stuff like that. Right.
Right. I think that's all of that is absolutely correct. And it helps to make a point that I've often tried to communicate in my work, which is that when we look at misinterpretations and ambiguity and how ambiguities are resolved, we're not doing it because we think this is a general problem in language. Garden path sentences, for example, don't happen very often in real language. What we're trying to do is to uncover the mechanisms that the language processing system uses. And just like we have to invent devices for telling us, giving us measures that we can use to record what's happening. We have to invent sentences or stimuli that kind of crack the system. They break. So by the reason we like sentences with ambiguities in them, or sentences that are likely to be misinterpreted, is because in some ways, by showing where the system breaks, we can get an idea of the mechanisms that are involved in normal language processing. So we know, for example, that people seem to treat the heads of phrases as particularly important. And we know that on the basis of these experiments that we've done that manipulate whether there's a garden path or not. And the point isn't what happens in garden path sentences. The point is, how do people interpret heads of phrases? And heads of phrases, of course, occur, by definition, every phrase has a head. So heads of phrases are all over the place. So that's just one example to make the point that, yes, exactly what you say is true, which doesn't mean that it's pointless to study these weird sentences or to look at how people misinterpret each other, but that it tells us what is the architecture that's enabling the language system to be so robust.
No, of course, the point I was making was just that perhaps we don't have to be too worried about misinterpreting language because someone might misunderstand what you were saying there, or what I was saying just a few seconds ago, and think that, oh my God, we're misinterpreting language all the time.
Right. Of course, there are situations, like in a courtroom, for example, where you have to be very careful not to get misinterpreted. But fortunately, normally we're not being questioned or grilled about anything, so we don't have to worry about that level of precision. When you teach also, though, you're very conscious of the fact that you can get misinterpreted. You can say something in a way that's unclear, use a word that a student doesn't know, that you haven't bothered to define yet. So a lot of language processing is about not only saying what you want to say, but formulating a model of your interlocutor so that you can produce utterances or write sentences that are likely to be understood. So the burden is not just on the comprehender to understand, but the burden is also on the speaker or the writer or the signer to produce sentences that are appropriate to the person they're communicating with.
Mm-hmm. So still on the topic of fluency of language production, does it have any relationship at all with individual differences, like, for example, in terms of intelligence and executive function?
Yeah, so that's something that I looked at in some of my earlier work. And I mentioned the work that we had done on ADHD, and there is some evidence that comprehenders, well, so let's take an obvious example like vocabulary. So a component of language production is producing words, and producing words that fit the meaning that you're trying to convey as accurately as possible. That's going to be related to the size of your vocabulary. And we already talked about lexical diversity in the context of, older adults who've had more time and experience in which to acquire bigger vocabularies. We also know that whatever you might think of the validity of standardized assessments like IQ tests and GREs and things like that, a big component of those tests is vocabulary. And so the people with bigger vocabularies tend to end up with higher scores on things like IQ tests and other kinds of standardized assessments. And so that would suggest that there's a relationship between IQ and language production, but it's really probably mediated by other things that we don't really understand very well, like how that vocabulary is acquired, what kinds of experiences have gone into the opportunities that people have had to acquire vocabulary. And then some of the factors you've also mentioned, like inhibition. So the relationship between inhibition and other cognitive systems is something that we're only beginning to understand, but there are teams of researchers like Al Kim and Jared Novak, for example, who've been focusing heavily on the role that inhibition might be playing in individual differences in language processing. So I think it's a really interesting question. I think it's really, really hard to study because there's so many dimensions on which people can differ from each other. But in general, it's almost certainly going to be the case that individual differences in cognitive skills are going to correlate with language production and comprehension skills as well.
By the way, on the topic of comprehension, in what ways does redundant information contribute to it?
Okay, so that's a really big question. Right, so redundancy in language has been a topic that it's motivated linguistic and psycholinguistic theories for decades and decades. And it goes back to the Gricean maxims about, to be brief is, one of the things you're supposed to do. And being brief means don't produce any unnecessary words. And there are views currently of the efficiency of the language processing system that kind of go along with that idea that, generally speaking, uses up metabolic, is metabolically demanding. So I want to communicate my ideas as efficiently as I possibly can. Redundancy would seem to be inconsistent with that goal. So Bryce would seem to be on the right track when he says that people should not be redundant. But as more and more work is showing, speakers are redundant and listeners benefit from that redundancy. So, for example, what Grice would say is that, for example, I should not call this a green pen. I should just call it a pen because there's no other pen right now in the discourse. So to include the color modifier is pointless. It's information that you don't need. But what we now know from a lot of research is that, for example, color as a trait is an extremely salient property. And in fact, there's research showing that I'm more likely to call this a green pen in English. This is work by Rubio Fernandez. I'm more likely to call this a green pen when I'm speaking in English than I would if I were speaking in Spanish or, say, Portuguese, because the adjective comes first. And if I'm speaking in English and I'm going to say by producing green, what I'm referring to, because in this context, I can't quite see what's in my background, but the green things are this pen, maybe that plant, and the stuff outside the window. So by producing a redundant adjective, or at least an adjective that isn't necessary in the context because it's the only pencil, I actually will help you to identify the referent more quickly. And we also know that people say things like repeat again. And repeat again is redundant. And I have a PhD student working with me named Casey Felton, and he's looking at people's production of things like lift up. So in English, we say lift up the table, but the meaning of lift is to elevate.
Yeah, yes.
And so you don't need that particle. In theory, it is truly redundant. But this is so common in regular language. We say add in, subtract out, mix together, combine together. It's just all over the place.
Yeah,
So
all of those expressions, redundant expressions, we also have in Portuguese. Like, for example, repeat again, we say repete outra vez, something like that. So we're always saying that as well.
Which suggests that it's a general tendency on the part of humans that they are redundant. So I think then the question gets to be, well, what is efficiency? And efficiency isn't just producing the fewest syllables per unit of meaning. It could be efficient to provide listeners with redundancy because it does give them multiple opportunities to get your message. And we had just been talking about the opportunities for misinterpretation that are in language, and how perhaps in real conversations we're not so bad at understanding each other. Maybe it's because we're redundant, and repeat again is technically redundant, and your teachers would yell at you for saying that. But in real life, if I'm teaching my class and I say, okay, I want you to redo this again, I tend not to say that, but imagine if I said, I'm giving my students 2 chances to get my meaning. I give them the re on redo, and I give them again as a separate word. And now my meaning becomes clear. I see this a lot in, I don't know if you ever do like online exercise videos and things where the instructor will say, okay, so let's repeat that again. And, you know, because it's really important that you understand that we're going to now do the same exercise that we just did. And, you know, you need to understand that that's what's coming next. So repeat again is very healthy or helpful, healthy. There was a speech error. So in general, I think redundancy is valuable, partly because listeners' attention wanders, and they might not know what you meant at this point, but they will know what you mean at a later point in the sentence. So there's more and more of an appreciation and a respect for redundancy in language, that it actually benefits the comprehender and allows the speaker to convey their message more clearly. It also is just less abrupt. So lift that versus lift that up. You know, the up is somehow gentler. It makes the instruction a little bit gentler. And I don't quite know what's going on with that, but I have that as an intuition.
Yeah. So I have 2 more topics I would like to ask you about. We've already mentioned eye tracking several times here today. So how do you actually study reading and information processing through eye tracking, and what can we learn from it exactly?
So we know that the eyeball is structured so that so we know about the retina on the back of the eye, you know, the collection of cells that are responsible for our ability to process visual detail, especially the cones, right? The cones are the cells that are allowing us to read, essentially, or to extract visual detail. And this foveal area of vision is actually quite small. And what that means is that we need to make eye movements in order to process the information in the environment. And eye trackers capitalize on that fact. So when we read, and imagine we're reading text like English or Portuguese that's read left to right, top to bottom, our eyes will land on right around the middle of a word. Typically, it's a little bit left of center, but right about the middle of a word. And then we move our eyes to the next word. And then we move our eyes to the next word. And we're basically reading each and every word in a text, except for words like the and of, which we tend to skip over, probably because we can see them in our peripheral vision. And they're also highly constrained contextually. So when we look at a visual scene, it's the same thing. So when you look at like what's behind me, you can get a sense in one fixation that you're looking at some kind of a home office. But in order to identify what are the actual objects in the scene, you have to make fixations all around it. You know, that there's a clock over here, and that there's a picture on the floor for some weird reason underneath the window, you know, etc. So what this means then is that the position of the eye is giving us information about what the comprehender is attending to. So if I want to know what word you're currently processing when you're reading some information on a computer screen, the position of your eyeball is going to tell me that. So what I need is an eye movement monitoring system that essentially records the position of the pupil that tells me where you're looking. And that eye movement recording system allows me to identify the exact word that you're currently looking at, and even the character within the word that you're looking at. In fact, that you can even get more precision than a single character on a computer screen. So what we've learned from this kind of eye tracking research is that, as I mentioned, people tend to fixate on each individual word, except for some highly predictable, highly frequent words, and that the fixation durations, so the length of an individual fixation, correlates with the difficulty of the word that's currently being processed. So a word like cat would receive a shorter fixation than a word like feline, because feline is a longer word, but also because it's a less common word. And we also know that when people get garden path sentences, when they get to the part of the sentence where they realize they've messed up, they will exhibit long fixations, and they'll also do multiple fixations. So usually you only fixate on a word once or twice, but if the sentence has become confusing, you'll look at it multiple times, and you'll actually also make a backwards eye movement called a regression, as if you're sort of going, oh, this is hopeless, let me start again here, and you go backwards. And skilled readers make a lot of regressions. It's not a sign of failure, it's actually what efficient reading looks like. So we use the eye movement monitoring system, or eye tracking, to give us, I mentioned before that language processing comprehension is private, but we can actually make it a little less private by monitoring the position of your eyes. I can tell, if I put you on an eye tracker, what word you're looking at, how long you're spending on that word, how long the eye movement is over to the next word, etc. And that gives us a lot of valuable information about information processing during language comprehension.
So I have one final question then. This is a topic that is, I guess, unrelated to the others to some extent, but when it comes to language learning, and I guess that many people out there would be interested in language learning because they are parents or educators, so they are interested in knowing if we can improve language learning, particularly in children, I guess. So can singing facilitate language learning?
Oh gosh, that's also a study I probably should have suggested we not try to go into in too much detail, because I'm going to tell you. So what I'm going to do is I'm going to hijack this part of our conversation to tell you a little bit about how we often do science. So
Okay.
that study is a complete one-off. It's a study that I did with Katie Overy and her PhD student at the time when I was at Edinburgh, and I served on the committee of the graduate student who was working on that project. And what we showed in that study is that, yeah, it looks like singing can help people to learn, a second language. But that was a study that I worked on completely as just sort of, like I said, this one-off. I've never really pursued it again, so I couldn't tell you what the current literature on that topic looks like. I also would emphasize that that study focused on learning second language. I believe it was Hungarian that she was focusing on, and she used that just because it was unlikely that very many of the subjects we would want to test already knew Hungarian. Or maybe it was Czech. See, I can't even remember what the second language was that we were looking at. But that's probably a different process from what we see in first language learning in children. Although we know that teachers and educators, parents like to use songs as a way to teach kids words. Maybe it makes them more memorable, makes them the repetition helps them to learn. Also, it helps children, I think, to learn phonological patterns. So in song, you tend to get rhymes. And so rhymes are going to facilitate phonological awareness. And phonological awareness, we know, is really important for learning how to read. In fact, you might know, I don't know if you know about the studies that were done a few decades ago on Portuguese illiterates. So people who after the revolution were put into literacy programs in Portugal. So adults who had never had the opportunity to learn to read. And so like, his name is escaping me, a Portuguese researcher who's spent most of his career in Belgium, did a lot of these studies along with José Alegria and some other people. Anyway, they showed that people who do not read and write, adults who did not know how to read and write, had very little phonological awareness. They could tell you how many syllables were in a word. They kind of intuitively understood things like syllables, but they didn't understand things like phonemes. And once they learned to read, these same adults could tell you that a word like stick has 4 sounds to it. Whereas prior to literacy, they would say it had maybe 3 sounds to it. If that. Anyway, so all of that is to say that phonological awareness, which could be something that is conveyed through music, helps people to become literate, or is a consequence of becoming literate. It's probably both a cause and a consequence, and in that way is sort of related to language learning. But here I'm kind of speculating, and I'm in some ways out of my specific area of expertise. So.
No, that's fair enough. So, Dr. Ferreira, just before we go, would you like just to tell people where they can find you and your work on the internet?
Yeah, so you can find me in Davis, California, most of the time, or in San Diego, where my brother lives with his child. My brother's also a psycholinguist, at the University of California, San Diego. But on the internet, if you Google my name, usually I will come up pretty much the first or second item on your search. There is a Fernanda Ferreira in Brazil who's a volleyball player. That's not me. And if you Google Fernanda Ferreira Davis, then you will find me pretty easily. So yeah, I'm easy to find. Fernanda Ferreira, as I tell people, is a very common name, but not so much in cognitive science. So
yeah, probably in Portugal it would be much more common, I guess.
And Brazil, it seems like it's quite common in Brazil. So yeah. When people say your name, it's so unusual, it's like only here.
Great. So I'm leaving some links to your work in the description box of the interview. And thank you so much again for taking the time to come on the show. It's been a real pleasure to talk with you.
Thank you for the opportunity. I've really enjoyed this conversation. So thanks.
Hi guys, thank you for watching this interview until the end. If you liked it, please share it, leave a like and hit the subscription button. This show is brought to you by Enlights, Learning and Development Done Differently. Check their website at enlights.com, and also please consider supporting the show on Patreon or PayPal. I would also like to give a huge thank you to my main patrons and PayPal supporters: Per Ergo Larsen, Jerry Mullerens, Frederick Sunda, Bernardo Seixas, Olaf Alex, Adam Kessel, Matthew Whittingburg, Arno Wolf, Tim Hollis, Eric Alenia, John Connors, Philip Forrest Connolly, Dan Demetrio, Robert Windiger, Rui Inácio, Zup, Marco Neves, Colin Holbrook, Phil Kavanagh, Michael Stormir, Samuel André, Francis Ford, Tiago Nunes, Fergal Costa, Hal Herzog, Nuno Machado, Jonathan Labyrinth, João Linhares, Stantantia, Samuel Correia, Eric Hines, Mark Smith, João Eira, Tom Hummel, Sardas France, David Sloan Wilson, Yacila Dez Araújo, Romain Roach, Diego Londonho Correia, Yannick Punter, Dana Rusmani, Charlotte Bliss, Nicole Barbaro, Adam Hunt, Pavlo Stasevski, Nelek Bach, Guy Madison, Gary G. Alman, Sam Afzal, Adrian Yeager, Paul Tolentino, João Barbosa, Julian Price, Edward Hall, Edin Bronner, Douglas Fry, Franca Bortolotti, Gabriel Ponce Cortez, Ursula Litsky, Scott, Zachary Fish, Tim Duffy, Sonny Smith, John Wiseman, Daniel Friedman, William Buckner, Paul George Arnaud, Luke Loaki, Georgios Theophanes, Chris Williamson, Peter Wolozin, David Williams, Diogo Costa, Anton Erickson, Charles Murray, Alex Shaw, Maury Martinez, Coralie Chevalier, Bangalore Atheists, Larry Dealey Jr., Old Erringbone, Sterry, Michael Bailey, Dan Sperber, Robert Grassi, Igor N., Jeff McMahon, Jake Zool, Barnabas Radix, Mark Campbell, Thomas Dovner, Luke Nissen, Chris Story, Kimberly Johnson, Benjamin Galbert, Jessica Nowicki, Linda Brandon, Nicholas Carlson, Ismael Benzliman, George Coriatis, Valentin Steinman, Per Crowley, Kate Van Goller, Alexander Hubbard, Liam Dunaway, BR, Masood Ali Mohammadi, Perpendicular, Jonas Hertner, Ursula Goodenough, Gregory Hastings, David Pinsoff, Sean Nelson, Mike Lavigne, and Dios Necht, A special thanks to my producers, Isar Webb, Jim Frank, Lucas Stafiniak, Tom Vanagdam, Bernard Ugnik, Curtis Dixon, Benedict Mueller, Thomas Trumbull, Catherine and Patrick Tobin, John Carlo Montenegro, Alnick Ortiz, and Nick Golden, and to my executive producers, Matthew Lavender, Sergio Quadriano, Bogdan Kanivets, and Rosie. Thank you for all.